Welcome to my YouTube channel, A Brainery of Civil.
Today I am going to solve the first assignment of reinforced concrete road bridges. Okay, are you ready? Okay, let's start. So you can see first question, the steel grade Fe 250 means. Fe 250 means yield stress or yield strength is equal to, that is Fi is equal to 250 Newton per mm square, okay, or we call it is 250 MPa. Megapascal means Newton per mm square. In the earlier assignments I have explained how to convert megapascal to Newton per mm square. So for this question the answer is B. And coming to second question, as per Indian Standard Code 10262 2009. So this 10262 will describe mixed design, concrete mixed design. Okay, so for M20 grade concrete, the standard deviation value is, standard deviation symbol is sigma. So for M20 grade concrete. So now standard deviation, what is the purpose of, what is the usage of standard deviation? To calculate mean strength of concrete. To calculate mean strength of concrete, Fm FCK plus 1.65 sigma. Here sigma is equal to, depends upon the grade of concrete. So sigma value depends upon grade of concrete is, sigma is equal to 3.5 when grade of concrete M10 to M15, and sigma is equal to 4.0 M20 to M25, and sigma is equal to 4.5 M30 and above. Okay, so for M20 grade concrete this value is sigma is equal to 4.0. The answer is B to this question. Next question, a reinforcing bar embedded into two concrete section, that is here one concrete section and there is one more concrete section. This is a reinforcing bar which has been embedded into two different concrete section, and load will transfer from this section to this section. Okay, whenever a vehicle is moving here, so load will transfer from this section to this section by this bar. This bar we call it is double bar. Generally this will be used in highways, that is concrete pavements. Okay, so the answer will be option A for this question. And now next question, the earth retaining structure supporting the superstructure at the beginning and end of the structure is called, generally we call it is an abutment. So if you, this is an abutment diagram and there is an highway, yes, and this is earth mass and there is a bridge here. Okay, so this is a river, the river water, here it is, river water is flowing like this, river is flowing in this way. Okay, so this bridge is a superstructure and this is a earth mass. So this structure we provided here, it is called abutment, and he mentioned that at the beginning and at the end. So this is a beginning and this is end. So both superstructure and earth mass is supported by abutment. And there are some intermediate columns, like they are called piers. Okay, so for this question the answer is abutment, answer D. Next question, arrange correct order of component of bridge from top. So first one he has given girder and bearing and cables and weep holes. Generally the components will be, so first one is cables and the second one is girder and third one is bearing and fourth one is weep holes. So this order is very important. So you will get the answer is C. So that is 3, 1, 2, 4. Clear? Next question. Mechanical system which transmits load from superstructure to substructure is called. Okay, so obviously it is girder. So girder means it is a mechanical system. You can write definition, the meaning of girder. Mechanical system which transmit loads from superstructure to substructure. So the answer is B for question number 6. And next question, the span of simply supported beam is 15 meters. So I am drawing this diagram. So simply supported means it is a beam having supports, one is hinged support and another is a roller. A concentrated load 120 kilonewton is acting at a distance. So he has given span of the beam is 15 meters and at 3.5 meters from left support, this is 3.5 meter, he has given it is 120 kilonewton load is acting. The bending moment at mid span is 7.5 meters from left, because 15 meters is the total span. First of all, we will calculate support reactions. So there is one support reaction at A, R, B, and RA plus RB is equal to 120, and I will take moment about B is equal to 0. Now this RA will create clockwise moment and this 120 will create anti-clockwise moment. That is RA into perpendicular distance is 15 meters minus 120 into perpendicular distance is 11.5. That is 15 minus 3.5. You will get it is RA is equal to 92 kilonewton. Okay. So to calculate max bending moment at, let I am taking it is C at center. So bending moment at C is equal to, that is RA into 7.5 minus 120 into 7.5 minus 3.5. So that is, by substituting the RA value as 92, we will get the answer is 210 kilonewton meter. Okay. So it is kilonewton meter and the units here are kilonewton for the load, and the distance, the span of the beam is 3 meters. So product will give you kilonewton meter. It is not Newton mm. Okay. So answer is C for 7th question. And next question, the span of simply supported beam is 10 meters. He has given it is, the span of the simply supported beam is 20 meters. A uniformly distributed load 25 kilonewton meter is acting on the first quarter. So for quarter it will be 5, 5, 5. So this is 5 meter, this is 5 meter, this is 5, this is 5. On left quarter there is a load 25 kilonewton per meter. So 25 kilonewton per meter is the load acting on the left. So I will calculate support reactions, first RA, RB. So first of all, RA plus RB is equal to how much? 25 into 5 is 125. So this uniformly distributed load is acting for 5 meters, it will be 125. I am taking moment about point C, about point B. Okay, that is sigma MB is equal to 0. RA into 20 minus 25 into this uniformly distributed load acting like a point load at this point, at the center of UDL. This will be 2.5 and the remaining will be 15. So it will be 17.5 is equal to 0. From this you will get RA is equal to 109.375 kilonewton. Okay, this you will get from calculator. Okay, so now what he asked, calculate maximum bending moment at midspan, that is at C. That is bending moment at C is equal to RA into, at center the distance is 10 meters minus 25 into, from here to here the perpendicular distance, that is 5 plus 2.5. If you substitute the value of RA as 109.375 kilonewton, you will get maximum bending moment is 156.25 kilonewton meter. So 156.25 kilonewton in meter is answer D for the question number 8. Now question number 9 and 10 are the same questions, but the answer he asked is in different way, different solutions he asked. So just listen carefully, this is a very important question. So what he asked, the span of a simply supported beam, he has given the span is 10 meters. The distance between front wheel and rear wheel is 5 meters. For example, so here there are two wheel loads. So the distance between these wheel loads is 5 meters. The front wheel is 80 kilonewton and rear wheel is 120 kilonewton. Okay, and the front wheel, he said it is front wheel FW and RW is rear wheel. The maximum bending moment in the beam is equal to, that's what he has asked. Okay, so now the question is, first we will take the loads. So this is 80 kilonewton load and this is 120 kilonewton load. I am assuming the resultant of these two is summation R is equal to 80 plus 120, you will get it is 200, which is acting at a distance x from 120. Okay, according to moment area, let us take moment about point A here, that is at 120 kilonewton is 0. So that is 80 into 5 minus R into x is equal to 0. So x will be is equal to 80 into 5 divided by R is equal to 200. So it will be 8 5s are 40. So that is 400 by 200, you will get it is 2. X is equal to 2. Okay. So that is here the resultant is acting at a distance 2 meter from 120 kilonewton. To get maximum bending moment under 120 kilonewton, we have to place 120 kilonewton load and the resultant on either side of the center point, equal distance. Okay. Now the distance between R and 120 is 2 meters. So let I am taking it is center. So that is 120 kilonewton is on right side and R is on left side. So this is R. So this is 120. So the distance between R and 120 is 2. If it is 2, then this will become 1 and this will become 1, because we need to place R and 120 equal distance from the center. Okay. Now I decided the exact location to get maximum bending moment under 120 kilonewton load. Okay. So if we know the location of 120 kilonewton load, then obviously I can able to calculate where is the load, where is the left side load. So that is here. This will be the distance between 120 and 80 is 5 meters. This will become 3 meters. So there, here it is 80 kilonewton. Okay. So now this is RA, this is RB. So for this loading beam, for this loading of the beam loading of the loads, now you will get support reactions RA plus RB is equal to 80 plus 120. So that it will be 200. I am taking moment about B. RA into 10 minus 120 into this distance will become 4. 4 minus 80 into 5 plus 4, it is 9 is equal to 0. So RA you will get it is 120, RB you will get it is 80 kilonewton. Clear? That is, here in this case, placing of load and resultant load is the most important to get maximum bending moment. So now we will get maximum bending moment at 120 kilonewton load, because out of the given two loads, 80 kilonewton and 120 kilonewton, 120 kilonewton is the maximum load. So whenever the maximum load he has given, we need to place that maximum load and resultant at equal distance from the center. So now bending moment at 120 kilonewton load is equal to, that is RA into 5 plus 1, it is 6, that is 120 into 6 minus 80 into 3 plus 2, it is 5. You will get it is 320 kilonewton meter, 320 kilonewton meter. So that is maximum bending moment will be equal to 320 kilonewton meter for the given loading condition. Okay, and in this you can say the distance between left support and 80 kilonewton load is from here to here, it is 5, 3 here 1, here 3, here it will be 1 meter. So this is 1 meter. The distance between left support and 80 kilonewton load is 1 meter. So that is the information he has asked in the next question. So you can see the distance of front wheel is what? 80 kilonewton. From left support is 1 meter. So in the last solution I explained. This is the answer for last question. Okay. So it is D for 10th question. So this is 4-week program, reinforced concrete road bridges. So there are only 4 assignments and this is the first assignment I have solved. So if you have any doubt, please post your comment. If you like the way of teaching, so you can subscribe my channel. Thank you.